And at this point, I'd like to introduce Valentine Lehr, a professional engineer with his own firm, Lehr Consultants International, and he is a preeminent engineer on the topic, many other topics, but on the specific topic that he's speaking about today. Welcome, Mr. Lehr.
Basically, I want to thank Margie for inviting me. She always comes up with such interesting topics. We do work all over the world, and water tanks are everywhere, and yet it's something we hardly ever think about. So, as we start, since we do all of now we'll get going. So, I travel a lot, and it's very interesting as you travel. You get to some very interesting places. So, for example, my wife being of the Irish persuasion, we have been to Ireland quite a number of times, and anybody who's been there, especially in Dublin, knows that the city is known for its doors. Fantastic series of doors. Everywhere you go, they're really nice. The doors of Dublin. And if you go to Paris, and I'm in Paris quite a lot, we have a lot of work in Paris, the roofs of Paris, if you, at various points in the city, you see the vantage point, you see all these fantastic roofs. And Paris is classified and known for its roofs. And if you go to England, particularly outside the London area, almost every little hamlet has these fantastic gardens. You have the gardens of England. So what are we known for here in New York? We're known for the roofs of New York, the water tanks of New York. A little less romantic, but far more practical. So I've been asked to talk a little bit about water storage and particularly sanitation. And I thought I'd put this together in a way that hopefully clarifies things. So tank applications. Well, basically in the city of New York, we use water storage tanks for two purposes. One of those is for domestic water. And the majority of the tanks you see on the roofs are in fact domestic water tanks. But in addition to that, because of the fire regulations, we also have a series of tanks which are used for water storage for fire protection. And we also have a series of tanks which can be used as a combination of domestic water and of fire protection. When visitors come to New York and we talk about the roof tanks of New York, one of the questions that's always asked is, why are they elevated? I mean, after all, you have this beautiful city and you look and you see all these things on the roof. Why can't you have them on the rooftop without sticking them up in the air? And why can't you, for example, put it on the top floor in some unused area? Why do you have to have them elevated? And the answer is relatively simple. You know, if you have a street pressure, and in New York City, the pressure in the water mains in the streets is about 50 psi, it brings water up only to a certain height. You can't feed the Empire State Building, for example, from the water main in the street in one shot, because the pressure results in an elevation. And generally, you want to have a 20 psi minimum water pressure for the type of applications that you all represent. Well, in order to do that, you have to have enough pressure. Well, if pressure can give you altitude, well, then the reverse is true. Altitude gives you pressure. They're interchangeable. And so consequently, if you have a pressure of 20 psi as a requirement, for example, the fact of the matter is that 1 psi will raise water about 2.3 feet. It's actually 2.31. So 20 psi raises the pressure to a point where the water can be lifted 46 feet. And so if you want to have at the top of your building, at your highest most fixtures, a 20 psi, which is what you need to operate flush-type water closets or to get a decent shower, the water tank, its lowest level, has got to be 46 feet plus something for friction above the fixture. So that's why tanks go up. And this little device will tell you that the height of the water gives you the pressure. You don't need large volumes. A little tube of water at 46 feet will give you the same resulting pressure as will a huge storage tank. But they're elevated because you need the pressure. And so if you begin to take a look, there's lots of different types of water storage tanks. For example, the most frequent one is the one that you see over there on the left, and that's a wooden type tank. These are wooden staves, they're held together by hoops, and those are the most frequent tanks that you find. They have an incredibly long life, they're very efficient, they're easy to put together, they can be transported up in an elevator. It's an easy type of installation. If you went back to the 1920s, there probably were 200 manufacturers of water tanks. These days, if you get around and take a look, there are only 2 major manufacturers left. But they happen to be the most frequently encountered water tanks that you see. Now, they also have water tanks, as you see in the illustration on the right-hand side, which are steel. And the steel tanks certainly work quite well. The problem with steel tanks is twofold. Number one is they're very difficult to put in place. They're not usually fabricated and welded and riveted on site, so they have to be brought up and lifted, and that requires a lift with a crane, which is an added complication. And I particularly chose this picture because if you look at the water tank on the extreme right, you'll notice those very interesting brown, orange-brown stripes. That's called, if you haven't guessed it yet, rust. And so consequently, there's a fair deal of maintenance on those tanks, which you don't encounter in a wooden tank. So that's basically the types of tanks that you'd find on a roof. But not all water storage tanks are on a roof. Very often, you have water storage tanks which are located within the building or elsewhere. And the most common of those are these prefabricated modular tanks. These tanks are called Braithwaite tanks. That's after the original British manufacturer who conceived of the idea. And they come in 2 types. The one on the left happens to be one which uses metal panels. And since these were originally built in the United Kingdom and Europe, the panels are not measured in feet and inches, but in meters. So a standard panel is either 1 meter, which is a little bit more than 3 feet, or 1.2 meters, which is pretty close to 4 feet. And you can build these tanks as long and as high and as wide as you like. But obviously, when you start putting these little panels together and bolting them together, one of the things that happens is the panel gets big enough and you fill it with water, the internal pressure tends to bend the panels outward. And so the photo on the right-hand side up on the top shows a series of tie rods. And when you put these panels together, you also internally put tie rods which absorb the pressures which would tend to blow this thing out. In our international work, unlike New York City, which has an extremely reliable water supply in many areas, you don't have that, and you have to build huge volumes of water storage. For example, 2 weeks ago, we have an office in Saudi Arabia, in Jeddah. We're working on a new large hospital project, and sure enough, we got a water main out in the street. And that water main will deliver a huge quantity of water, but it's only turned on 1 day a week. And so what we have to do is we have a water storage of 10 days, 7 days because we know it's at least 7 days before the water is turned on again, and a 3-day cushion in case somebody forgot to open the valve up and we don't have water. And those tanks are all these types of Braithwaite tanks because they're easy to put together, they're extremely reliable, and they can be configured into all sorts of configurations. What you're looking at here are rectangular tanks. These can be made L-shaped, cross-shaped, triangular, T-shaped. You can put it together in any way, and you can fit it into some extremely difficult locations inside a building. And by the way, if you look at the tank on the lower right-hand side, the one that has a sort of goldish color, that's one that's not made of metal, that's made of fiberglass, reinforced fiberglass. And we prefer the fiberglass tanks because even though the metal tanks are well protected, they do require maintenance. You have to worry about corrosion, and so consequently, what happens is that we prefer the fiber tanks because once the gaskets are set, those things tend to last for an awfully long time. The other type of tank you can appreciate is a concrete tank, water tanks. These are underground tanks, for example. There are a fair number of buildings in New York City that have water tanks, concrete water tanks in the basement. That's also something that's put together. But I also chose the other photo. It happens to show that inside the tanks you have to have a fill line, you have to have access, you need steps because you have to go in and clean these things out on occasion. So there's a lot of things that happen inside the tank. Also, to keep the tank filled, there's some control devices that allow you to fill the water, make sure it doesn't overfill and what have you. So that's the array of tanks that you're likely to come across. And there may be some other variation of it, but more or less that's the type of tank. There is one other type of tank which you will find, and that is in older buildings, and that's a tank which is the hydrodynamic tank. When you originally, before the advent of the newest tankless type pumping systems, had to increase the pressure and you didn't want to put a roof tank in, it was possible to develop a system which had a large tank which had a cushion of air. And when you pump the water in, you pressurize the air, and that gave you pressure. And this type of system was an early type of system that was used particularly in buildings which were, for example, from 6 stories to 20 stories. This was a very typical type of system that you might find in the 1920s, 1930s. It is also a type of system which you will find in many buildings today at the top of the building that's associated with fire services, where you need to pressurize the fire services, sprinklers and fire standpipe at the top of the building, and you do it with this type of a hydrodynamic system. Today, you'll find that these are not normally around. And because of the small volume and quick turnover, the water in those tanks stays in those tanks typically under 1 hour, except perhaps overnight where it might be a bit longer. These do not present a major sanitation problem. All right? I don't think there are any other type of tanks that you would find in the type of commercial, residential, hotel, hospital structures that we all have in the city of New York. There are other types of tanks we use, but they're for other reasons. So let's talk about the sanitation issue. So essentially, this is a tank. This happens to be a brake tank that we use. This is for an actual project of ours. And you notice at the bottom of the tank, you've got all of this sediment. Every water storage tank will sooner or later accumulate sediment at the bottom of the tank. And where does it come from? Well, it comes from a variety of locations. For example, it comes very neatly with the fact that our water mains, as good as the New York City water supply is, do carry debris through. That debris comes through from the fact that the supply pipes rust. Occasionally, we have a water main break. When they have the water main break, you go in and you dig up everything and you try to clean it up and replace it. It is not always possible that the new piece of pipe that went in was perfectly clean. In all the excavation, some dirt winds up, that gets carried across, and sooner or later it winds up at a terminal point. A nice tank is a quiet, quiescent atmosphere. The material settles down. The problem with this is that the material probably is not dangerous in itself, but it is a place that harbors bacteria. As a matter of fact, in some piping where the velocities are low and you have sediment building up, the sediment itself promotes corrosion of the pipe because certain bacteria corrode the pipe, and what you have is under-deposit corrosion. The corrosion, that material, that sediment, harbors the bacteria which eats the pipe up. It harbors a variety of bacteria. So if bacteria or organisms get into the system, they can hide out in that kind of sediment. That's something of concern. That's why you have to clean the tanks out frequently. The other thing is, and it's difficult to see in the screen in this light, But what we're looking at here is a water tank, and the stuff that you see, the discoloration, is floating on top. Who has actually ever climbed up on the roof and climbed up that rickety ladder on the side of a tank, sprawled out on the sloped area, opened the door up, and physically looked into a tank? Show of hands. Ah, we have a couple. Anybody ever see any interesting sights?
Dead birds.
Dead birds, dead rats, dead mice. You have all sorts of stuff up there, because as much as you think that that's an isolated and safe place with a roof, as water goes up and down, it is either expelling or inducing air in. The air's got dirt, bacteria, and dust, and pollen and everything else. It comes into the tank, and it settles out slowly, and it floats on the surface. Birds come in, they get trapped in the space, they die, they float on top. So this happens to be a reality. You don't want to necessarily go to your tenants and say, well, by the way, let's take a tour of the house tank. But the simple fact of the matter is it does get to be a problem. And those are really the two major elements that one has to be concerned about in terms of sanitation. So it is for that reason that there is actually legislation that says you have to do something about it. Oh, sorry, that's another photo, and that one happens to show the other thing you find in tanks, which is mosquitoes. You know, mosquitoes breed in water. In Singapore, if you have standing water in a flower pot, you get fined about the equivalent of $500 because it is breeding place for mosquitoes, and mosquitoes bring malaria. Thankfully, we don't have malaria here. Having suffered malaria myself, you should be very happy we don't have it here. But notwithstanding, that's another thing you find up there. So what happens is that we have, this is a potable water issue, we have a regulation. This comes from the New York City Department of Health and Hygiene, and here's the application. And basically what it says, that the owner, agent, or person in control of the building shall have the water tank inspected at least annually. And it tells you what you have to do in terms of inspections, and it tells you what you have to do in keeping the tanks clean. So there is a legal obligation for you to do the inspections and make sure that you don't have floating dead birds or other creatures or other types of problems that go with it. So there will come a time when you have to clean a tank. In our work abroad, where the water supplies are so really bad, we provide a lot of water storage. We never provide water storage in a single tank, because in those areas, if you drain a tank down at a point when there isn't water available, you shut the whole operation down. So we always have tanks in multiple compartments, so you can keep at least half of the system in operation. So what do you do in terms of tank cleaning? Well, there's a couple of steps. First, if you have to empty the tank, and then you have to scrub the interior surfaces. Okay, and that's a procedure that is quite interesting. Normally, those tanks are then disinfected with chlorine. The particular material that's used is the calcium hypochlorite. Now, I got to tell you something that's very interesting, because I've actually been there when this has happened. When you go and you put a person to clean something in a closed tank, you go back to the first thing you picture. Here's the tank, and here's the roof, and here's the access. Guy goes in, takes out all this chlorine and starts to throw it around and scrub the walls and everything else. The fumes can easily overcome a person. And you can overcome the person to the point where they collapse. And if you go and try to rescue the person, the rescuers can also be overcome. We had an incident of that only the other day out on Long Island. It happened to be carbon monoxide, where people were overcome with that, but it happens in water storage tanks. So when people clean, they have to go in not only with a respirator mask that protects them, but actually with an oxygen supply to make sure that they're not overcome. And that's also an area of potential liability. One has to be careful about that. So after you've disinfected it, you have to wash it down and flush it, and really wash it down, and what you have in the bottom of the tank has to be flushed out, drained out. Fortunately, most of these things are on the roof, and if you drain them onto the roof, they go down the roof drain, roof leaders and go out in the storm system. Okay. In that regard, though, there are a bunch of things you also have to remember. If there's firewater storage in the tank, you must notify the fire department, telling them that their fire storage is out of operation. That's a mandatory regulation, and you can be, again, cited if you don't do that. Use approved chemicals and materials. This is drinking water. So anything you use has got to be food grade. You can't go to some, Schmucker Club 500 cleaning solution, which is marvelous for getting things clean in the garage. You've got to use something that is compatible with the drinking water supply. You have to protect the workers, and that mainly means when they go in and do this, provide them with an air supply system so that they're not overcome by fumes. I want to just go back. We had a swimming pool at home, and quite a long time ago, my wife and I were putting the pool to bed for the winter. So during the year, we'd use all sorts of different types of chlorine. Chlorine is chlorine. So at the end, I wanted to really douse the pool and fill it up and bring the chlorine level up to help the winter storage. So I wound up taking 3 different types of chlorine, 3 different brands of chlorine that I used, and I mixed them together. And all of a sudden, this thing erupted and went ba-doom. There was this cloud of chlorine gas. I took 2 lungs full, and it took me 4 martinis in 3 weeks to recover. I can tell you, these things, when they happen very rapidly. So it's something you really have got to be careful about, because you don't want to be injuring the people who are doing this kind of work. But more importantly, you got to protect yourself. So it really is important for you to take some readings. We have chlorine in our water supply, and we're supposed to maintain a residual chlorine content. Residual chlorine content should be somewhere around 0.1, 0.15 parts per million. Take a reading. If you've got that, then you are relatively sure that you have got sufficient chlorine to take care of bacterial contamination. If you don't have it, figure out why you don't have it and do what's needed to do that. And while you're doing it, it's not a bad idea when you take it to record it, so you have a record of the readings you've got. I think that's an important factor. And then you really should also, at least once a year, take a sample of the water, not the water that comes in from the city, but the water you're sending out to your tenants in the building. Send it off to a laboratory and ask them to do both a chemical and bacteriological analysis and see what you got. That is just decent protection for everyone in the building, including yourselves. And then, these days, people also like to do their own treatment to make sure that everything is good. I'm sure that many of you at home have your own water filters on your drinking water. I'm sure that you have a whole variety of different types of facilities which are used. And we'll talk about that in a minute. But as I was talking about this whole subject of sanitation, somebody said, good, you'll deal with RPZs. And I said, well, that's very interesting. I don't think so. Because RPZs, or reduced pressure zone protectors, they're a hot topic, but they are intended to protect the public water supply, the water in the streets. They are not intended to protect your building. And they do that by preventing a backflow from your building into the street. Well, if you're feeding a water storage tank, the water storage tank prevents the backflow. And all that the RPZ does is prevent the water that's in the pipe that's going up to the tank from flowing back. But it does nothing to protect you and protect your building. And storage tanks form a natural break that doesn't do anything. So therefore it's not critical for tanks, right? But internal protection, the sort of stuff that we talked about, taking the tests and applying the various things, that is important for you. So what do you do in terms of disinfection? Well, if someone chooses to do it on a central basis as opposed to individual apartments, individual tenants, you can consider three types of systems. First is ultraviolet. This uses ultraviolet tubes. The ultraviolet radiation kills almost everything. It does not kill all viruses, but it kills almost anything. It's a very effective means. It's used in all sorts of things. If you notice that on every table here I can see bottled water. Do you know that every drop of bottled water is treated with UV before it's put in a bottle? And it effectively keeps the bacteria from doing anything harmful. You can use reverse osmosis. You can use ozone. All of those are methods that can be used. It is generally not used because a good bit of the water in a building is used in water closets. You don't need to treat it in a water closet. So, but if you're going to do something, those are the things that you want to be doing. So with that, I thank you for your attention and questions, comments, or verbal abuse. I'm particularly good on verbal abuse.
We have Alex Weiss. Alex, if you want to go to the microphone there.
Hi, Alex.
Thank you, Valentin, for this great educational presentation. And I have a question. So, as you mentioned that the water in a city, drinking water, is of high quality. And so the water treatment in individual buildings should be used in each individual building, and if this treatment should be used to cover deficiency of maintenance of the tanks.
Okay, that's, I think, three questions. Let me try it once. Number one is that the maintenance of the tanks is your primary treatment of water. Because if the tanks are maintained properly, the quality of the water coming in is very high, and basically the tanks will do nothing to reduce that quality. So the maintenance of the tank itself is a treatment process. Secondly, with regard to ancillary treatments such as the ozonation, the ultraviolet, the reverse osmosis, there are many people who are sensitive to chlorine. They want to get rid of the chlorine that's in the water. And there are other people who feel that certain minerals or certain other types of facilities are detrimental to their personal health, and they provide their own individual treatment. So I would think that the individual treatment is the more logical thing to do. However, I have also come across a variety of people who want to treat the water centrally so that everybody enjoys the benefit. And if you do that, then the types of equipment I showed are there. In our applications in many areas of the world, particularly in medical facilities, we do central treatment before it goes out. And in the instance I was talking about in Saudi Arabia, we're not doing that because the water is 100% desalted water, which comes in as almost pure water. And by the way, the cold water is 115 degrees when it comes in, and we don't have to do water heating, we have to do water cooling. In order to, if you want to take a shower in a hotel, if they haven't provided the water cooling, you turn the hot water on and the cold water on, and you don't use the hot water. But I hope that answers your question. Okay.
Thank you.
Yes, sir.
What protection would you recommend in tenant buildings, single family, where there really is no...
Just as ordinary, yeah. The question was, what would you recommend in a single pipe system like a tenement? Just so everybody understands what that means is that if a building is low enough, the street pressure by itself feeds everything in the building. And so consequently, the pipe comes into the building and it goes up and it feeds everything. And the answer is, in that type of a situation, you literally have the water, the raw water coming in with the only potential for contamination is whatever rust comes off of your pipe if you have a ferrous type pipe. The only practical thing if you want to do treatment in that is literally to go and put a terminal unit on something under the kitchen sink or something of that nature if a tenant wants it. but you don't necessarily do any maintenance on that at all. And that's also the regulations deal with the storage tanks because of the sediment and the undergrowth of that and the floating material.
Question.
Yes, sir.
Hi. Thank you very much for a great presentation, by the way. When I was younger and dumber, I used to climb to the top of tanks all the time to look at them. Every tank I ever looked at had the dead birds, the dead mice, the dead this, the dead that. So I'm sure the majority of tanks have them. Why are people not getting sick left and right from all these tanks of, you know, dead bird soup that we're...
Because, yeah, that's a good thing. Dead bird soup. I have to think about that. I have a nephew who's a chef. Maybe it's a new item we have. Actually, what happens is that is a very common occurrence. There's a couple of things. Number one is that the water volume that comes in and the turnover in the tanks gives you continual makeup of water, and the water that comes in does have a high chlorine content, and basically you're feeding the water in the top and you're drawing out the bottom, so there's a huge contact time. So any contamination at the top, by the time it makes it to the outlet, has had the opportunity to be disinfected by the residual chlorine. That's why it has not been a major problem. Now, having said that, if you go back to the health department and you search around enough, you will find some instances where there have been building-wide outbreaks.
Thank you.
Okay.
Thank you very much, Mr. Lehr. Thank you, that was excellent. Greg, NYARM Board President, Greg Carlson.
I want to, first of all, thank everybody, all the panelists that we had today. Good afternoon, everyone. Did everyone have a good time at the dinner dance, right? Well, a funny thing happened to me on the way to the dinner dance. Another car decided to bump into me, and instead of having fun at the dinner dance, I was having a real great time in the emergency room. So for those, I missed you and look forward to with next year. I have the honor and privilege of late last year being elected president of the National Association of Housing Cooperatives. That's our national arm. And a couple of things that we are really, really pressing. First, is Steve Israel's FEMA bill that will include cooperatives and condominiums in any disaster relief funds that are available by FEMA. And and I just want to point something out. I want to thank Steve Elbaz, stand up Steve, okay? He has been great talking to the press as we're trying to get press out there and this issue known. We're also working with FEMA, and it's funny because I just came from our first union negotiation today, face-to-face, that 32BJ is also helping us on regulatory and legislatively with trying to get FEMA to include co-ops and condominiums and all associations. The second thing on the federal level is we want to have veterans be able to purchase a co-op. The Veterans Administration says co-ops are not homes. You know, I live in a co-op. I think it's my home. But it's been very, very tough, but we've been at this for decades trying to get that approved. But lastly, on the national level is, you know, ever see all those commercials about reverse mortgage, right, how good it is and build up equity? Well, they're not available for co-ops. Why? The legislation was passed, but HUD has not issued the regulatory regulations in order to make that happen. So those are the things that we're working on nationally. Locally, as you all know, we have a new administration, we have a new city council, and it's going to be a fun 4 years for all of us. Right now it's too soon to say which way they're going. I know they've been having lots of meetings with people and different industries, And I think they're trying to get a, you know, a learning curve to find out what the real issues are. So, with that being said, let me tell you, you come to these 907 seminars, you'll be the first to find out what's happening. Either A, don't forget, the union contract expires April 20th of this year, which happens to be Easter Sunday. So, we will, you know, well, I'll keep you up to date as best and as I can to tell you that, because there are some things when I sit at the table, I can't tell, you know, until this whole thing is over. But we are, both sides want to reach a fair and equitable new 4-year contract. And I did not say Happy New Year because I couldn't, because I was in the hospital, so I'm wishing you a Happy New Year today, and please keep in tune. Thank you one and all.
Thank you, Greg. That was, I don't want to say it was extremely lively because it was fabulous. Thank you. Okay. 1 minute. Okay. You've all seen these. We're going to hope you each take one home. This is a swab kit. NYARM sells these. They are prepaid lab test kits. It's $150, not for asbestos or lead, but for everything we've been talking about today, organisms and bacteria and things that grow diseases. So as you want to determine, do you have bed bugs in your building? Well, they leave a DNA trail. Are there mice? Are there rats? Is there MRSA? Whatever it is. For $150, you get to mail this away. You would have prepaid it. Within 24 hours, you'll get an email telling you what the organism was. They test the DNA, okay? So this is one of the ways that NYARM is finding allied products or services that we can promote and sell and use as funding sources so we can continue to bring these fabulous programs to you. Okay. Our next meeting is going to be March 20th. It's the Thursday of the 2-day Building New York show at Javits Center. We've been doing this for the past couple of years now. We have our seminar there. It's 12 noon on Thursday. So the NYARM meeting will be our gathering place for March. So you'll be hearing more about that. But the topic is we will have Howard Rothschild, who is the president of the Realty Advisory Board, the leader of the union negotiations. So we'll be right on the cusp of that. And the topic is the politics, ethics, and legalities of strike management. Workers versus owners, versus residents versus contractors. So it's not just going to be an update on what's happening with the union, but we all know those 3 weeks leading up to a strike. And God forbid, the 2 days or 2 weeks of a strike, the politics that are involved, how the residents get involved, what the contractors are going to do, what you're going to have to mothball. We're going to want attorneys to tell us, well, you've got these contracts, you've got contractors, you've got all sorts of obligations going on. How do we manage that within the politics as we lead up to it? You know, it's our staff scaring the contractors, our contractors saying we won't cross the picket line. What's the right thing to do? What's the wrong thing? So we'll be covering that at that meeting, as well as having Howard Rothschild report to us directly. The last thing is we have our quarterly magazine. I encourage you to advertise in it. It is a content piece. It's not a news item. So it stays on the desk longer and it's a reference, and we are coordinating it with our meetings now. So you'll see articles in here, you'll see this on YouTube, you'll see links into the articles, and so we're coordinating it all for you. And the last announcement is our exhibitors. We have Epic Security, who you're going to want to sign up for your security guards beforehand. We have Bug Lab ID, okay, we have Bug Lab. We have the veterans donating your clothes, and we have Rosa Parks Tank. Okay? And with that, I'll see you all at all the other association meetings, and I will see you hopefully on March 20th at Javits. Thank you very much for being here.